In this problem, I have a hair placed at one edge between two flat glass plates, and I'm going to illuminate it with light, and I see a bunch of bands, and I want to know how thick is the hair, right? This isn't like a weird question. Like, this is actually something you can do, and we've kind of seen this in class, right? But just writing it in words, it looks kind of weird, right? So let's draw what's happening here. So I have a glass plate, right? And then there's a hair that comes over here, and this hair is really exaggerated in size, right? And then this other glass plate sits on top of the hair, right? So it's going to look like that. So these two plates are at a difference to each other, right? They're not directly on top of each other. And I'm going to have some light, right? So I'm illuminating with 541 nanometer light. So this light comes in here, right? So it comes like this, and then it's going to bend when it goes through the glass, right? It's going to bend here. And then some of it is going to reflect, this interface right here. Some of it is going to reflect here and bounce off and come back, but some of it is going to pass through, right? So here's two options. I have one, it can bounce here and go through, or two, it can bounce, come down to this bottom plate, come back through here, go up, and come out, right? So that's option 2. There's two paths, right? I can either have the light get reflected at the interface of the first plate in the air, or it can get reflected at the interface of the air in the glass of plate 2. And doing that, you're going to end up with an interference pattern, right? So this is what's happening here. So let's look at, we got to count the number of phase shifts, right? So first, we need to get the number of phase shifts, right? So there's going to be a phase shift at the second interface, but there's not going to be an a phase shift at the first one. So remember, a phase shift depends on the index of refraction you're going into or out of, right? So this is 1 and this is 2, right? So 1 hit glass, it was going from glass to air. That was going from glass to air. So there's not going to be a phase shift. So there's no phase shift at number 1 because it goes from glass to air, right? But then at 2 is going from the air, right? That's coming from the air here into the glass. So this is going from air to glass. That's going from low index to high index, right? So there is going to be a phase shift at 2, right? So there's one total phase shift, and it's not going to be at the first one. It's going to be at the second one, right? So that's one phase shift, okay? So we're going to count dark bands. The first band is going to be dark. We're going to count dark bands, all right? And since M starts at 0, right, that means that M starts at 0. Therefore, 120 bands, right, 120 bands is going to equal an M of 119, right? My M is going to be 119 because I started with 0. Right? If I have 120 bands that I see, that means M is 119 because I'm not starting 1, 2, 3, right? If I count from 1, 2, 3, 4, 5, that's 5. But if I start with 0, 0, 1, 2, 3, 4, 4 is 5, right? I started with 0. So 120 bands is 119 M, right? So whatever, in this case, whatever my number of bands is, my M is 1 less than my number of bands. Okay, and so now, right, now it's easy. I figured out the stuff I need to figure out. I know there's one phase shift, right? So since there's one phase shift, I'm going to use the whole multiple equation that we've talked about in class, right? Remember, there's two different equations, right? I can't spell. Remember, there's two different thin film interference equations, right? They depend on whether you're using a whole multiple or a half multiple. So one phase change equals the whole multiple equation. So 2 times the thickness equals M lambda over N, right? And so that means if I want to solve for thickness equals M lambda over 2N, right? And the index of refraction of air is 1, right? It's basically 1.000, whatever, right? So now that I know that, I can get the thickness, right? And the thickness is how far apart those two things are, right? That's going to be this distance here, right? And that's got to be the width of the hair, right? So it's really, thin film problems aren't that bad. you have to decide first. You have to draw it out what's going on, right? You have to find the number of phase shifts, because the number of phase shifts determines like where you start, but it also which one you're going to use, right? So in this case, because there was one phase shift, I used the whole multiple equation.